All right, so we're moving into section 5, partition matrices. So notice I have this matrix A here, capital A, that's made up of all kinds of different matrices, right? The lowercase a mean individual entries, but capital A means matrices. So let's look at what we've got here. So A11 is this, right? So to put together my capital A matrix, I'm going to put this in the first row, first column. All right, so let's move to this A12. So this is first row, second column. So 4, 3, 9, 7. And let's move to first row, third column. So that would be negative 2, 1. All right, so now moving down to A21. A21 is this, negative 3, 2, 4. And then A22 is 8, 2. And then A23 is 5. So that gives me a 3 by 6 matrix by putting the different matrices of different sizes together. All right, so let's look at this one. Here I have the capital B is made up of these two. So this one's a little easier to put together. So 6, 4, negative 2, 1, negative 3, 7. And then B2 is right underneath. So negative 1, 3, 5, 2. So that is my matrix B. So asking us to find A times B. So A times B, if I was to think about it, so this is a 3 by 6 matrix, right? And this is a 5 by 2 matrix. Wait a minute. If A is 3 by 6 and B is 5 by 2, this cannot be done. They're not the correct sizes because you know these have to match. So can't be done. All right, so let's look at this next one using partition matrices in a different way. So here I have A. So first off, they want me to show that A squared is I. Okay, so 1, 0, 3, negative 1, 1, 0, 3, negative 1. So if I multiply, so let's make sure we're good at the multiplying because we have to do it by hand sometimes. This row times this column, right? So 1 times 1 plus 0 times 3, that gives me a 1. All right, this row times this column, 3 times 1 minus 3 times negative 1 times 3. And then a little different color here just to make sure we're all, so you see what I'm doing. This row times this column, so I get 1 times 0, so that's 0, and a 0 times negative 1, so that's a 0. And then this row times this column, so 3 times 0 is 0, and then negative 1 times negative 1 gives me a positive 1. So simplified, this gives me a 1, a 0, and a 1. So that does turn out to be I, right? I sub 2. Okay, so they want us to create the partition matrices to show that m squared is equal to I. So if I think about this, looking at this, thinking, I see this is A, this is 0, this is I, and this is negative A.